Hey, this is a video of me going over my project for artificial intelligence. So I feel like my in-class demonstration didn't really do my code justice, so I'm going through and explaining my final program. So some of the problems I ran into was there were quite a few issues with from the start with my program. For example, I had little knowledge of game programming, especially from scratch or with a light framework like Pygame. Secondly, there was little involving implementing any AI pathing using Pygame, and the examples and documentation that I found were sparse and very different. Um, Examples usually involve solving some form of maze using A-star algorithms, a maze with a static start and end goal, a maze that was built on a grid system, and all of these involved a starting point and an end point that you could place before running the algorithm. The walls would be generated and they'd be taken into account before the algorithm ran. With my program, since it involved moving objects, there was no static starting place. The end goal was always moving with the player character, and the walls of my maze could be placed at any time by the character in positions the computer would have to immediately calculate. So we'll start at the beginning. You import Pygame and import math. I use the math for the heuristic function. And then initialize Pygame. Pygame has to be initialized. So I set the static variables, the screen size, background color, the red color, and the grid multiplier, which are of little importance apart from the grid multiplier. Then I created the player object. So you want to create a rectangle using Pygame's rect function at any x and y position, x, y, and then the size x and size y, as you can see here. Then I went on to define a handle keys function, which allows you to move the player. So it takes WASD keys into account and moves the rectangle and records the direction of that movement using the x and y variables here. The direction of the movement comes into account when you collide with a wall. That makes it so you can't move past any rectangle object. The get location function wasn't used in the final code here, but it was there from previous versions. The draw self function draws the rectangle to the screen. All of the objects have this function. The follower has a rectangle that it creates. It's the same size as the player. A, a node that is a placeholder for the node that it needs to move to, and the path and closed are used to keep track of which ones it's visited and which ones it needs to visit. These would be more implemented for an A-star search, whereas they weren't implemented in mine. Not implemented in this greedy searching program. Next, I created an artificial intelligence function for the follower. So we get the player location using the getPlayerLocation function. I guess I did use that after all. And we split it into x and y coordinates. Then we grab the location of the follower using the self.rect.center and split it into x and y coordinates as well, which makes it easier to work with. Next, I wanted to create an area around the follower that would activate some nodes. I'll show you in the actual running of the program what that area looks like. So then we're going to run through each walls, and if there's a collision with a wall, you're going to stop moving, which isn't the correct way to do it. The move in place 00 did not stop movement since it was reset immediately after colliding with the wall. The way to do that would be to get the direction and set the same collision like we did for the player here. However, it was hard to get the direction of movement since it was essentially moving towards a node. I didn't have a clear idea on how to do that. So the collision with walls function does not work for the follower. Next, I set a low value of 99,999, just a really high value to make sure that the heuristic was lower than that to start with. So we're going to loop through our node objects. So for each node in the nodes list, we're going to check if it's activated and if it's not a wall. If it's activated and it's not a wall, then we'll get the heuristic. And if it's less than the low, which at this point is really high, that will be the new low, and we're going to set the move here node equal to that node. Then we'll move the rectangle to the lowest distance node. This right here is the move in place function, so you'll move yourself to, this is the speed of movement really in the x and y coordinates. If you didn't do it this way, it would be very jumpy. Then you'll draw to the screen. Get node area was something I used for debugging so that I could see the node area around before I was able to display it. And let's see. Okay, the which function or which nodes function calculates the active nodes. Let's see if it's inside of the x area and inside of the y area of that 24 by 24 square around the follower, then the node is activated. If not, it's false, and if it's not in either of them, it's false. So you want to deal with the nodes that are only in that immediate area to cut down on the cost of the program, I guess. The location also helpful to return. Next, you have your wall object, and in the initialization of the wall, we are grabbing the location by returning the position of the mouse. And the way that works is when you click, it will create this wall at that mouse position. So we're going to separate into x and y coordinates as well, and then we're going to add the wall to the walls list. Initially, you want to set rotation equal to false, meaning the wall will be a horizontal rectangle, as you'll see. And then this was just to make it a little bit harder on myself, I guess. I wanted to add a rotation feature so that you could rotate the wall and create a vertical wall. This created a few nodes on the wall that weren't used in the end. This is left over from testing that I had done before. And it also has a draw function. The next class is the node class. It initializes a location and then an x and y coordinate of the location and a rectangle for the node. Let's see. So you set the activated to false, or else all the nodes would start out as true, and the purpose of that safe area that you're checking for nodes around the follower is there's no reason for it. If it is in collision with a wall, then you set it to wall. That will become more apparent in a second. And then you add the node to the nodes list. Next, you're going to draw it to the screen. Okay, get heuristic. This is our straight line distance to the player from each node. So you get the player location, separate it into x and y coordinates, and use the math.hypotenuse function to get the straight line distance to the player and return that. The isWall function, this is where that if wall, then return true, if else, return false. So if it is a wall, you're going to check the area in a 16 by 16 area around the node. So, well, it'd be more like 32 since it's 16 on the left, 16 on the right. This is why the wall collision is not very accurate. The nodes are not the walls themselves. It's checking if a wall is within that node area. Making this bigger would exclude more node space, but it wouldn't really check for collisions with walls. It's just going to make more nodes walls, which essentially makes them non-activated. So for each wall in the walls list, you have to do this each time if you want to calculate it for each wall. The wall size is the rectangle size of each wall, and the location is the wall location. Then we get the x and y coordinates and check if the node is inside of that safe check area range. So that safe check area is the box around the node, and we're checking if that box is within the wall range. And if it is, we set that to true. And I threw this on here at the end to kind of check if it was colliding with the wall. So if the self.rect is colliding with the wall using Pygame's collideRect function, you set that to true. I don't know if that had any effect or not. The grid class initialized with the screen size and then an x and y coordinate of that screen size. And then the place node function was essentially to create nodes everywhere on the screen in the 16 by 16 or 16 space between each of them. So that's what that does. Okay, so now we're going to set the screen to the screen size and the title of the screen to complex AI. Then we'll create a player, we'll create the grid, we'll create the node list, we'll place the nodes, and then we'll create the follower and the walls list. We'll set running equal to true. Clock equals pygame.time.clock. That means you're starting a clock that will make sure the program runs at consistent speeds on all machines. Okay, so I print out to start the follower AI, hold down Q. That's something I added later, so it was a little more beneficial to the user. So if you wanted to place walls before activating AI, you could. So while you're running, we're going to fill the background color. We're going to check for events. If you click on the X in the corner, it's going to quit. If you click on the screen anywhere in that play area, it's going to create a wall. Then we're going to draw the player to the screen and handle the keys, so his movement. Then we're going to draw the follower to the screen and check for keys. And if you're holding down the Q key, we're going to activate the follower's artificial intelligence. We're also going to check which nodes are active. And for each node inside of the nodes list, if it's activated, and if it's, you're going to check if it's a wall. Then you're going to get the heuristic for each node, which will print out in the console. And for purposes of this, I'm actually going to uncomment and draw the nodes. That takes a little longer to run, but it's easier to visualize how the follower is choosing which path to take. Then we draw the walls and update the display, and we set the clock tick to 70, which I believe means 70 frames a second. Alright, so after we save that, we're going to run the program. And as you can see here, to start follower AI, hold down Q. So I'm going to do that really quickly just to show the nodes around the follower. So as you can see, he's got a select bit of nodes around him. It's taking a long time to run because it's drawing these nodes after looking through all of them. But as you can see, he's moving towards the player, and the ones that he's been to are going away, and he's choosing the quickest path to the player. Now when you come into contact with a wall, the issue I had was similar to the hill climbing problem, where the follower would not want to move away from the closest node, and there were not any closer nodes that weren't walls. It's taking a long time to run this, so once he gets to this wall, I'll uncheck that draw nodes and then run it as it is. So as you can see, he's trying to choose a node that's closer that's not a wall, and sometimes it works. And as you can see here, the collision isn't properly detected with the wall, but it still does it. It's trying to get around the wall. I'll close this and uncomment this part. Run it one more time. So as you can see, it's supposed to move a lot faster. We'll put a wall into place, and this is that hill climbing problem that I ran into. There are no nodes closer to the player inside of this area that are not a wall, so it's not going to choose one that's less. So as you can see, if I move over, there is a node closer that's not a wall, so he moves to that. It should work for that too. Well, I guess there isn't a node closer that's not a wall. So it does a decent job of trying to get around these, but it's not perfect. But you can still rotate walls as well, and it tries to get around the walls. It would be more accurate if I had more nodes in place. Instead of doing 16 by 16, I could do a node for every pixel on the screen and check if that pixel was a wall, and then just move around that way. That would work a little more accurate with collision detection. Then he would never come into contact with walls, since every node actually was part of a wall instead of just being in an area that it is. But that's pretty much it for my code. Thanks for watching.